Problem 19. In a certain card game, a player is dealt a hand of 10 cards from a deck of 52 distinct cards. The number of distinct unordered hands that can be dealt is written as that. What is the digit of A? Well, first of all, the number of distinct hands that can be dealt. What is that? Well, that is just 52 pick 10, right? Because we want 10 cards from 52 that are unordered. This is literally the exact definition of combination right here. Or this notation. I forgot the specific name, but that's the 52 pick 10 is exact. Oh, sorry, combination, not permutation. Permutation is where it's ordered. Combination is where it's unordered. So this is literally the exact definition. So what is 52 pick 10? Well, 52 pick 10 is 52 divided by 10 factorial, right? 10 factorial, which is times 51 times 50 times what? 49 times 48 times 47 times 46 times 45 times 44 times 43, and you see where this is going, times 42 times 41, and all this divided by 10 factorial. So wait, no, do we add which is n at 42? So basically we had to first simplify this expression, and to do this, right, just simply expand it out, and then you can write it out as it is. Oh, wait, hold on, no, it's n at 42, because 52 minus 10 is 42, so we divide out 42 factorial, so that should be the final answer. Now, to simplify this, just simply write it out, and since I've already done it beforehand, just to save us on some time, you should have simplified this into equal 26 times 17, and let me refer to my note card, times 5, 7, 47, times 5, 47, 5, 47, 7, 46, 11, 7, 46, times 11, and then multiply out by the final number of 43, and that should be the simplification that you should have got. Now, with the simplification done, what can we say about it? Well, these are factors of the overall number, which is 1, 5, 8, A, 0, whatever. So basically, whatever these numbers are divisible by, it must satisfy this number as well. So first of all, let's consider special numbers. We know the divisibility rule for 5. It must end in 0 or 5. That's already satisfied. So we have 5 out the way. Let's consider different numbers. Well, let's break down some of these non-primes, right? So we know I'll circle green that are primes. That's a prime, that's a prime, that's a prime, that's a prime. So let's consider special numbers. First of all, let's consider 4. 4 is the divisibility rule. I'm just thinking about numbers that I know with the divisibility rule. So 4, the last 2 digits must be divisible by 4. So do we have a factor of 4? If we do, then it must satisfy this rule. Well, we know that 26 is 2 times 13, and we also know that 46 is 2 times 23. So 2 and 2 combines to get 4. Therefore, we do have a factor of 4. Therefore, A0, right, as a number must be divisible by 4. So what are my possible choices for A then? Well, A cannot be 1, it could be 2, it cannot be 3, it could be 4, it could be 5, it could be 6, 7, 8, right? So that's my total possibilities for A right now. But can we restrict A even further? Well, so basically we can eliminate this, we can eliminate, and we can eliminate 3. So what can we say about A further? Well, we also know if 4 works, and I suspect that 8 might also work, because 4 and 8 are very similar. When 4 needs the last 2 digits to work, 8 needs the last 3 digits to work. That's just a special rule, so let's consider 8. Well, if 8 requires the last 3 digits to be divisible by 8, then do we have a factor of 8 first of all? Well, this got prime factorized, right? This got prime factorized, and 43 is by itself is a prime. So we have no factor of 8. There's no factor of 8. Therefore, what can we say? We can say that A0, right, must not satisfy the rule where AA0 is divisible by 8. So how many numbers of A are divisible by 8? Well, 110 divided by 8, right? Would that work? Well, we put an A3, so that won't work. So A could be 1, right? What about 2? 220 divided by 8. Well, we could put a 216, 21660. That won't work. So that means 2 would work as well. What about 3? Well, 330, right? 330 divided by 8 won't work either, so it could be 3. And what about 440? Well, that obviously works. It cannot be 4. It could be 550 maybe. That won't work, right? That won't work. And what about 660 divided by 8? Well, that would not work, so 6 would work. And what about 770? But one thing to notice here is that, right, A can only be these possible numbers. So 1 and 3, right, cannot be 1 and 3, obviously. So we only have 2 and 6. So we can restrict down 4 and 8. That's all that matters. Because we cannot choose them. Because AA0, right, if it's 8, it would be divisible by 8. If it's 4, it would be divisible by 8. So it will only be 2 or 6. But which one? Well, let's consider another special number. Let's consider 3. 3 requires that the sum of all digits is divisible by 3. So what can that be? Well, what is the sum of all digits? 1 plus 5 is 6 plus 8 is 14. 14 plus 4 is 18. 18, how many a's do we have? We have 1, 2, 3, 4. We have 4 a's. Plus 4a must be divisible by 3. But we've already narrowed a to 2 or 6. So let's just plug in 2 first. If it's 2, 18 plus 8 is 26. That's not divisible by 3, and we have no factor of 3 within the prime factorization. Therefore, 2 must be our answer, and a must be the final answer.